IBEX is a NASA mission that will, for the first time, take a picture of the edge of our solar system, an area way out beyond the orbits of the planets, way out beyond Pluto, where the solar system interacts with the gas of the galaxy, with interstellar space itself.
The Interstellar Boundary Explorer has two cameras, and these cameras image the global structure of the boundaries that surround our solar system. They image these boundaries not with light, but with particles themselves. They've created a whole new way to image these structures.
Energetic neutral atoms start their life as charged particles, as very fast-moving charged particles. They get actually accelerated up to very high speeds because they have an electric charge. They're missing one or more electrons. As they're coming into the solar system, in this interaction between the solar wind and interstellar gas, they can, from another particle, grab an electron and become neutral. At that point, they're not affected by magnetic fields. They move in a straight line at high speeds towards whichever direction they happen to be going in at the time they neutralize. Some of those will be heading at the Earth, and those are the ones that IBEX is measuring.
IBEX is the first mission to actually understand the whole heliosphere.
The Voyager spacecraft, launched in the 1970s, have finally reached the first of the boundaries of the heliosphere. And they're taking wonderful and detailed measurements at 2 points at these boundaries. Instead, what IBEX is going to do is to go into an Earth orbit, a high-altitude Earth orbit, and look out at the boundary, not just in one or two directions, but in all directions in space. And by measuring particles coming in from those very distant regions, we'll be able to make an image of the interaction all around us.
The IBEX map is going to be more important than the 2 points that we get from Voyager 1 and Voyager 2 because we only have 2 points, but this is enormous. This is a structure that's billions of miles, and so just measuring in 2 points is like just having 2 buoys in the ocean and trying to figure out all the ocean currents from those 2 buoys. We have our 2 buoys, Voyager 1 and Voyager 2, and then with a satellite looking out instead of down, we get a map of the entire region with IBEX.
How does the Interstellar Boundary Explorer mission actually get to this very high altitude orbit, all the way up to the moon? The answer is that we use a Pegasus rocket, which is dropped from the belly of an airplane. The Pegasus rocket is going to actually get us into low Earth orbit. But in order to get to very, very high altitude, we incorporate with the Pegasus rocket another rocket motor. The launch of that gets us up to a higher orbit, and then we use additional propulsion on top of that to get us to ultimately our final orbit, which is almost to the moon.